So, back in 2017, a single research paper quietly came out, and it turned out to be the big bang for the generative AI world we're all living in today. It's called Attention is All You Need, and you can make a solid case that it's the most important AI paper of the last decade. Let's break it down.
And you know, that's not just hype. Before this paper, AI language models were built on a completely different foundation. This one idea, this new architecture, didn't just challenge the old way, it made it obsolete, practically overnight. It was a complete changing of the guard.
Okay, so to really get why this paper was so revolutionary, we first have to understand the world it replaced. Before 2017, AI language processing was all about one type of model that had a really serious fundamental flaw. It was incredibly slow, and it struggled to see the big picture. Just think about how you read a sentence. You go word by word, from left to right, building up meaning as you go. That's exactly how these old models called RNNs worked. They'd take the first word, process it, then take the second word along with the memory of the first, and so on. It's logical, sure, but as we're about to see, deeply inefficient. This slide really shows you the core difference. That RNN approach on the left, it's a linear, step-by-step chain. One word must be processed before the next can even begin. But the transformers approach on the right is a total game changer. Everything happens at once. It looks at the entire sentence simultaneously, which opens the door for massive parallelization.
And this table really illustrates the problem. For an RNN, the number of steps it has to take grows with the length of the sentence. But for a transformer, it's a constant number of steps. And get this, to connect the first and last words in a long sentence, an RNN has to pass that information down a long chain, losing the signal along the way. A transformer creates a direct connection, which is just way more efficient.
This whole one-at-a-time design created a huge problem that researchers called the information bottleneck. It's a really powerful idea that explains why the old models could only get so good before they just hit a wall. Imagine trying to summarize a long, complex paragraph into a single, tiny data point. That's what RNNs had to do. They would cram the entire meaning of a sentence into this one little thought vector, and then the next part of the model had to generate a whole translation from that one lossy summary. So much context and meaning was just lost in the process.
So the field was stuck. Models were slow, they struggled with long sentences, and they were hitting a performance ceiling. Then, in 2017, a team from Google came up with a radical new idea.
And this is the paper that changed everything. It was authored by a team at Google, introduced the transformer architecture, and its central claim was incredibly bold. This was such a radical idea at the time. The entire field was built on this assumption that to understand a sequence, you had to process it sequentially. This paper just threw that whole belief out the window and said, what if we just get rid of the recurrence entirely and rely only on a mechanism called attention? So, how does it work? Let's pop the hood and look at the 3 key mechanisms that make the transformer so powerful, all without a single one of those old-school recurrent loops.
Okay, this is the absolute core of the transformer. Instead of processing word by word, self-attention allows every word to look at every other word in the sentence at the exact same time. It calculates an attention score between them, figuring out which words are most relevant to understanding each other. It builds a rich network of context for the entire sentence all at once.
But it gets even smarter. A transformer doesn't just have one attention mechanism, it has many, all running in parallel. This is multi-head attention. Think of it like a team of experts looking at a sentence. One head might focus on grammar, another on the meaning of the words, and a third on how the pronouns relate to the nouns. Each head looks at the sentence from a different perspective, and their combined insights create this incredibly nuanced understanding.
So you might be wondering, if you process everything at once, how does the model know the order of the words? The solution is really elegant: positional encoding. Before the words even enter the model, a unique timestamp is added to each one. This gives every word a unique signal that tells the model exactly where it is in the sequence, solving the order problem without needing to process things sequentially.
So, the theory was brilliant. But did it actually work? Well, the results were stunning, proving the new architecture was superior in every single way.
And here's the proof. On a standard machine translation test, the big transformer model didn't just beat the previous state-of-the-art models, it blew right past them by over 2 full BLU points, which is a massive leap in quality. It was simply smarter.
And honestly, this might be the most important slide of all. Not only was the transformer more accurate, it was vastly more efficient. It achieved state-of-the-art results using a fraction of the computational power of its competitors. It was better, cheaper, and faster to train. And this efficiency is what unlocked the massive models we have today.
The impact of this paper went far beyond machine translation. It laid the architectural groundwork for nearly every major AI model that followed, from the chatbots we talked to the AI that generates images from text.
You can draw a direct line from this 2017 paper to the explosion of AI tools like ChatGPT and Midjourney. The architecture described in Attention is All You Need became the blueprint for everything that came next.
You know, the original transformer had two parts, an encoder for reading and understanding input and a decoder for generating output. What happened next was fascinating. Researchers realized they could use these parts independently. The encoder stack became the basis for models like BERT, which are masters of understanding context. And the decoder stack? Well, that became the foundation for the GPT series, the generative powerhouses that write text, code, and more. So, the transformer completely remade the world of AI. It proved that attention, applied in parallel, is an incredibly powerful tool for modeling language. But technology never stands still. The quest for even more efficient architectures continues, which leaves us with a final, provocative question. Now that attention has built our world, what will build the next?